Okay, so I think we're pretty much right at time. Chris, do we want to go ahead and get this started?
Let's do it.
All right, awesome. Well, thank you everyone for attending our Change Intelligence 101 webinar series here with Control Stack. So we have a couple of us here on the webinar today, so both myself and Chris. I thought it might make sense for us to just do a quick introduction of ourselves before we jump into the topics. So I'm Jason Gucher. I'm head of customer success at Control Stack. I've been working in the tech observability space for a little over 10 years now, working with primarily developers and engineers, SREs, to help kind of manage their stacks and understand the metrics that are flowing out and helping understand and maintain the health of their clusters. So really excited to be with Control Stack and excited to talk to you guys today about Kubernetes events and metrics. Chris?
Hi, thanks. I'm Chris Schellenbarger. I'm doing the head of, or leading up the DevRel efforts at Control Stack because I was a developer for 20 years and I understand a lot of the pains that I had to go through and what we're trying to solve for. Basically understanding all the stuff that Kubernetes does to alleviate pain for people, as well as trying to engage with the developer community and try to make your lives better. So that's basically my job, and also to be a developer's buddy. So if anyone has anything after this, deep technical or anything you want to talk with that, you can always reach out to me as well, or follow up after this.
Yeah, absolutely. So I appreciate that. Right? Yeah. Kubernetes is a great technology. I mean, it makes things a lot easier, but it adds a little bit of level of complexity in there when it comes to understanding, the events and metrics that are reported by your clusters and how to maintain the health. So glad to be here today to kind of talk about it in a little bit more detail. So primarily what we're going to start through today, we've got about an hour session here. We might take a little bit less, we'll see. We're going to talk quickly just about an introduction to Kubernetes and kind of what are some of the statistics that we see out in the market today. From there, we'll really briefly talk about the provisioning setup of a cluster, kind of what the states are inside your Kubernetes clusters and what those look like. From there, we'll get into a little bit more detail around the events basics and the monitoring tools that come into play. Kubernetes clusters obviously have a lot of events that they're emitting, and it's important to kind of understand what those events look like, which ones are ones that are problematic and ones that aren't, because obviously there's a lot changing in your Kubernetes cluster. So a lot of events are ones good to know, but maybe not necessarily record or mean a problem is actually occurring. From there, again, we'll talk about monitoring tools and some of the monitoring tools that are out there and how we can utilize those to really get a better understanding of the health of your clusters, and then talk about how we connect it all real briefly towards the end and how Control Stack can kind of help with that. So that said, let's go ahead and move on to the first slide. Just cleanups, I would just quickly say, if you have questions, you're welcome to post those into the chat. We have someone watching here, and we'll do our best to try to get those answered for you as they come in. Otherwise, again, you're welcome to reach out afterwards, and we can set up time for demos or answer any potential follow-up questions that you have that maybe you didn't get to ask during the session today. All right, so Chris, I kind of let you chime in, but clearly, I think what you see on here on the slide, we don't have to go through each detail. Kubernetes, the adoption of it is obviously growing, right? It's something that I've seen dating back 6-7 years myself, but the trends have obviously shown that it just continuously grows, right?
Oh, sorry, my mic. Yeah, so yeah, Kubernetes is growing. You definitely see it, from a developer point of view, you see it more and more on job recs when you're looking for new jobs. You're seeing more and more people talk about it. And you even see people kind of, it starts to bleed over into the developer world, right? You can't just be a developer in the world of DevOps today and just expect to write code. A lot of times they want you to know how to, know that your code's working, or at least help out when things go wrong. So you see a lot of people adopting Kubernetes today, especially because, I think people see the bigger companies using it too, right? And the dream of the product teams is to eventually have the scale, right? So a lot of times as engineers, we try to say, oh, we'll solve for scale up front by being on Kubernetes, because that way, on day one when we release, we have 1 million new users, we can just up the number of deployments, and we're good to go. But you see a lot of people around that. And you also see Kubernetes in use because it does actually solve some problems, even at a smaller scale. As developers, the old problems used to be when we'd have service outages, it would be when the processes on a machine would go down. So, we all used to have, even computers in our own closets or whatnot that would serve up websites, and they'd go down, and someone would have to go in there and restart a service, right? So part of the power of Kubernetes, just even at its most simplest, is that orchestration ability where it can actually like just restart things. And you combine it with containers. The other thing that used to happen is state would change. This is kind of bleeding into like containers, which isn't Kubernetes just uses containers to facilitate. But the nice thing about Kubernetes combined with containers is that in the old days a server could get corrupted. Like a DLL in Windows world or some shared library in Linux world would change, and you wouldn't be able to know what happened, and your service would just stop. So you have to like reload the whole box or whatnot. Nowadays, with a container, you just kill the container, bring it back up, and in theory, your state goes back to the original, right? So you don't have to worry about package versions, and that's really nice because now, as long as your system can come back up, things can crash, and as long as Kubernetes brings it up faster than your system is crashing, you can usually maintain availability versus the old days you used to have a lot more complete outages.
Yeah, no, so that makes a lot of sense, right? It keeps things going and abstracts the complexity from it, right? I think it really makes it useful in that case. Like, I guess one question I would have here, and just for those that are watching, I just kind of give a quick background for myself. Like, I don't have like a formal background as a developer engineer myself, but I've worked with a lot of folks in this space for several years. So I do tend to have a little bit more insight than just like your Joe Schmo on the street. But Chris, like when it comes to like production workloads, that makes sense. Like, is it useful to have Kubernetes from like the testing and staging standpoint? Like, it's easier to spin up new pods for testing when you're trying to get out your features there in your sprints?
That's a good question. I'd say if your production environment is using Kubernetes, it's useful, right? Because a lot of times you can take, the idea would be to take these same files and deploy it to your production cluster, but a lot of times you can get pretty close to it and replicate your production environment and config with Kubernetes production or staging clusters.
Yeah.
Versus the old days, just that same problem, right? You'd have staging computers that didn't have the latest kernel updates, they didn't have the latest package versions, and then your production cluster would be on different versions, and you'd ship, and you wouldn't, things wouldn't work. So with containers, especially in Kubernetes, yes, if you have a cluster and you're running, if you do it and you have identical configs, you can get a reasonably higher confidence that when you go to production, that your code that you had tested in staging will work in production.
Yeah, that makes a lot of sense. And again, I mean, I've seen it in the market for quite some years now. Obviously, we saw a lot of customers that are past startup that was using Kubernetes, and it's just using more. And as you mentioned, right, the workforce requires it these days, right? There's other orchestration tools out there that you could look at, but because it's leveraged so often today, like you just pretty much expect as you're moving from one organization to the next, like it's just a requirement or a skill set you have to have. So being able to understand this stuff and dig through those events and metrics clearly make a big difference. Do you want to talk a little bit about the provisioning kind of state of Kubernetes and what that looks like?
Yeah, so for, this isn't going to be a Kubernetes 101, like at the core levels. If people are interested in that, we can obviously give a different webinar on that. But this assumes you kind of understand the core parts of Kubernetes. And the one that we're talking about, or that's most related to what we're talking about today, would be the scheduler. As you see here, the schedulers are going to be responsible for, in Kubernetes, assigning workloads to the different actual like physical hardware resources. So those are nodes. In AWS, those are your instances, and GCP. I can't remember what the names are there, but basically your computers, right? They're nodes, and they become available for Kubernetes to provision workloads to them to run tasks, to run jobs, services, or whatnot. And today we're talking about particularly the scheduler is of interest to developers doing DevOps or operations, because the scheduler is the thing that emits a lot of events that you care about, right? So the scheduler emits every time it's making changes to the state of your running applications, whether it's taking down containers and pods and starting them up on another node, whether it's getting stuck trying to do so, or whether it's getting in a state where it's constantly restarting the workloads to the point where it backs off, right? So it starts to say, hey, I've restarted this a bunch of times in the last few minutes, so I'm going to back off and wait a little bit because maybe something will change and maybe a little bit longer. If we wait, it'll be better. And it also alleviates what's called the thundering herd problem, right? So without that back off intelligence, if you just had a very basic scheduler and it basically tried to restart until things came up and more things crash, you basically have what's called
never catch up.
Yeah, and the thundering herd, right? That and it's all the services coming back up can actually cause the thundering herd problem where everyone tries to reconnect, especially if you're using things like caching, especially if you're if you have a heavy startup logic, like querying databases to warm caches, right? All those caches warming at the same time could also bring down your system. So the scheduler is a little bit smart about trying to back off when it's trying to restart things and failing. But for our purposes, you see the scheduler is the kind of replaces the human of starting and stopping your processes, your workloads in your system.
Yes, absolutely. And then you have a lot of other things that come along with the technology and this structure, the architecture of your Kubernetes cluster also, right? Like you have things like the kubelets that are focused on kind of node resources, what's going on at the node level and making sure the pods and whatnot are running correctly and are spread across properly. But there's just a lot of stuff coming in, right? And you brought up like the back off stuff, which I think is kind of like one of those like I don't necessarily buzzwords, but one of the ones you hear a lot when you're talking about problems with Kubernetes and troubleshooting, right? I think a lot of people always pop off with the crash loop back off, and what exactly does it mean? Which is kind of like a decent segue when we start talking about some of the events that populate, right? Kind of going back to what I mentioned earlier on in this session, there's a lot of events that get emitted, right? The scheduler is there to kind of abstract a lot of the efforts that would normally be in place when you don't have kind of like a service provider or you're having to have an ops person maintain the visibility into your cluster. A lot of those events are perfectly fine, right? Things like starting up and shutting down. The idea is like as your usage changes, you want to reallocate where those pods are running at, what containers they are, how many replicas you have. Like it's a common occurrence, but you do have some of those events, right? Like the backoffs, and there's a lot of things that could tie into it, right? Like the crash loop backoff isn't necessarily the error in particular. It's not the actual reason for why it's in that state. It's just to let you know that something is happening when they're bringing up these pods, and they're going to back off on bringing them up so that you can look at it. It might be, like a typo in the configuration. When you start getting into metric stuff, you can think of like resources and the fact that you have requests and limits, but when you're spinning up, you're spiking too high to hit that limit, and it's just causing an issue there. So you really want to use some of these context clues on the events to understand where to then go and investigate next and kind of dig into it further with some of the metrics that they expose, right?
Yeah, Jason, I think for you, helping so many people be successful, using our products or other products that you've worked on, you kind of, if a customer has a problem, you kind of sit side by side with them trying to figure out if it's something on our side or their side. So you see a lot of this, right? So you've learned a lot about the different events that come up and what that means to customers versus necessarily what comes through to us, right?
Yeah, you definitely say that, right? And I tell you, luckily I've been able to work at strong companies that have given me some visibility into that stuff in a little bit more visual rich way, right? Obviously I think especially a control stack over the last couple of years, I've gotten much more comfortable with running things via command line and seeing some of the details that way. But the way I learned myself, like I need to be able to see the right visualizations to understand the connections between all of that stuff. So running Kubectl to see some of these events, and then if you have metric server, which we'll talk about in a second, you have that set up, like you can get a lot of the information you need, but it wasn't quite visual enough for me. So like I'm at least lucky enough to have control stack around to kind of help me out with that, especially as we move forward and bring on more customers and I need to support them in that way.
Yeah, that's a good point. And even for myself, and one of the reasons we want to do this webinar is because when I first started using Kubernetes, I actually didn't know about these events. So, you know, you would query Kubernetes with kubectl on the command line and things would kind of have an output and it would like aggregate these events, but I didn't realize they were emitting them, right? So, and you know, kind of, I'm getting ahead of myself, but you know, just to cover the basics of what Kubernetes events are, you know, just like events in any other system that you see, you know, just data, right? It's like, you know, describing one particular instant or that something happened, right? So an event is an individual occurrence of an event. So when the scheduler tries to start up things, it'll say, hey, you know, starting up the container. When it takes it down, it'll stop the container, right? You also have events, you know, related to your scaling, right? So, you know, if it starts to replicate pods out, you know, as you're getting more load, you want to make sure that, you know, part of normal operations, like Jason was saying, is like a lot of these things are normal things, right? That's the beauty of Kubernetes. Yeah, it's working perfect. If we're working nice for you, it's doing all these things for you. It's scaling up, scaling down, it's restarting, it's stopping things. It's doing what ops people, you know, 10, 20 years ago used to do in a much slower way, right? Because it would take hours or weekend deployments, right, to do these things, or we would scale up before holiday seasons at places
Yes.
that have holiday, you know, like big retailers, right? You know, used to scale their servers up, you know, before you know, Black Friday in November, right, and like kind of keep them there, and that's where I used to see outages too, right? Is, you know, we'd get, you know, people would hit their max capacity and the systems would crash, and then it would need some manual intervention. So like that time for manual intervention, heavyweight intervention, like was the outage windows. With Kubernetes,
Yeah.
you can turn it on and it'll monitor, you know, metrics and auto scale things based off of load. So it's probably one reason why you don't see too many major outages at the application level. Sometimes you see it at the infrastructure level, like when cloud providers go out, but I think in general you see a lot of systems, larger scale systems are more reliable than they used to be. If people remember back then when they weren't, but
it's interesting you bring that up, right? Like I think about cloud services, right? Like you have EKS and GKE, of course, and there's obviously other ones out there. They abstract a lot of that from like the actual management that you have to do. But to your point, like even in your example, right, it's more about like how do I scale out my stack when the need is necessary, right? When I have the requirements and the workloads coming in to be able to scale out. But there's also like the reverse side of that, right? Like especially as we kind of get into this market today, when you start thinking about what you're currently running and making sure that you're utilizing your resources accurately. It's the same general concept, right? It's like you can have things inside of Kubernetes that are looking at, you know, how things are actually being utilized at a node level and can scale back the pods and reallocate them and scale back the nodes in some cases based on certain thresholds. So like it not even like from the scale out, but it also scales down and can kind of help you kind of save money there too as well, right?
Yeah, that's nice, and especially coincides with, you know, things like AWS's spot instances when you're doing prices, right? And you can kind of, you know, there's tons of really cool stuff you can do. We're looking at, you know, getting more spot instances, bringing things up, but also reducing your demand for, you know, compute resources. Let's see what else, but you know, then also failures, right? Those other objects, right? You start seeing failures and you know, when pods crash and nodes unavailable. And I will say, like, you know, like, even for myself, learning about Kubernetes, it was difficult because I didn't know how to see like, oh, a lot of pods were failing or whatnot. The way it would manifest would be that, you know, something we'd be working on would stop working, right? And then, you know, as we were, you know, pre-market, you know, early startup, it would be one of our internal users or design partners using it, and that might be later in the afternoon, it might be the next day, right? So, you know, it'd been nice to have known about events and just been able to plug in and been able to at least be alerted when certain events that I cared about or when frequencies of any events became abnormal, right? And that kind of ties into the monitoring and alerting things that you would use as a DevOps engineer. Let's see, like what else we have. But yeah, so basically, the idea is that Kubernetes, if you look at kind of the philosophy behind how it's built, is like it's a very granular system, and it will emit events on every different thing that will occur in your system. And so, one problem with that is it's like too much signal, right? Too much noise, right? And so, just with the built-in tools, it's hard to kind of, and we'll talk about this in a minute, but like you can actually get, if you have too big of a system, too many things happening as part of your normal load, it becomes difficult to see, or even for a new person to reason about like what's going on in the system, especially if you use command line tools, you're tailing event logs. The same reason why log files themselves aren't useful after in any kind of production environment, when they're just spitting out lines faster than even a computer can process them.
Yeah.
So,
well, I think that's. Go ahead.
I just want to say one thing though, about Kubernetes events to know about, and whereas it would probably have led to me not understanding them enough, is one of the problems with Kubernetes out of the box is it'll keep events for, I think, out of the configured default 15 minutes. So when you look at a pod, and there's like some weird things going on, if it's happening within the last 15 minutes, that's good. But I had things where things just died and were killed, and why, and like the events weren't there, right? And so that's one of the problems out of the box with Kubernetes. So it usually requires people to ship their events to some other events aggregation platform, observability platform, or whatnot.
Yeah, no, I think that's a good segue over into the Kubernetes metrics, right? Like I think when you're talking about those workloads coming up and making sure that you're understanding it right, events are very rich, right? Like, and again, like a lot of these events, right? Like again, you could look at the logs and kind of understand what some of these events are tied to, but you still have to go parse through a lot of that information. And as you start scaling out the number of pods that are tied to a particular namespace, you have a lot of these unique identifiers. And then it's like just going through terminal, trying to like keep that mental model in your head about what's happening with one pod, what's happening with the other. Is this namespace wide? Is it deployment wide? Like what exactly is that error, right? Understanding that is sometimes tough. So like being able to have the visualizations, being able to look at metrics, I know was critical to me. And there's a lot of things that you can have in there, right? Like, and I think you'll mention this, but you obviously have to have metric server in the system, and you can use things like the Kubernetes dashboard to see a lot of those metrics and get some of those visualizations. But there is a limit to your point, right? Where it's like, you're only looking at the last 15 minutes. And it was like right before this session, I was even talking to you about, the issues that would pop up when you have like an overnight ops team. If you're like running around the clock for your team, and you got an overnight ops team making some configuration change that doesn't really populate into an error right away because like the workload just isn't there overnight. And 6 hours later, you got your next ops team, they start to see these errors are populating and rising up, but it started off so long ago. It's like, what's actually leading to that problem? You know what I mean? So it's important to be able to look at those metrics and kind of understand what's actually flowing into the system at any given moment in time. Again, resource utilization is critical. Your nodes and what they're reporting, what you're running, right? You've obviously got all of your pods and containers tied to your namespaces, but they have to run on some workload. And I think in a lot of cases, a lot of people are using things like EKS or GKE, right? They're using some service provided through the cloud providers. But understanding what those workloads are like can be very difficult, and metrics obviously help out with that. Again, to talk on the resource utilization, each of these configurations that you have going on inside your system, right? You have to understand what those workloads are like. And when you're looking at a node, you're able to set certain requests and limits onto your configuration. But that is across all of the pods that you're running, right? And it's important to be able to configure and be able to see, in my case specifically, like in a metrics evaluation standpoint, how you combine all of those requests together to understand what the minimum requirements are for all of the pods tied to your nodes, but then also being able to compare that to actually what your node requests are as well, and how you can compare that. So metrics are critical from that standpoint. Welcome back, Chris. It looked like you had a little technical issue, but I was just pointing out the importance of looking at things like request and limit metrics compared to your nodes, and being able to understand that, because again, things like crash loop backoff, like that's a pretty common occurrence, right? A lot of times people hopefully have request and limits set in place, but it's not a requirement all the time. So you might get to a point where you feel like you're okay to run that number of pods, but you start getting errors and spinning those things up, because overall the number of pods that are reporting, it's just matching over what the limits are for the nodes, right?
Yeah, and for me, for metrics, and I don't know if you touched on this, I apologize, a lightning strike here, so everything we said, but for me, you covered for me, it was not being able to see the aggregate of the events, right? So metrics here, other than like resource utilization and some other types of events, for me, when Kubernetes, if you look at events, you usually have to go to individual deployments or pods to see the events. But when you're trying to look and see like kind of how things are restarting and behaving in aggregate in your cluster, which is important, right? Especially when you want to start identifying problems right when they start, this is where metrics help, right? And Kubernetes, if you install the metrics server, will start to enable the ability to use like Kubectl top, right? And you can start seeing your resources, and then it also enables some endpoints that you can use to scrape and use to send metrics to another observability platform or internally. But just like events, metrics and events are good over time, right? So for example, when you have events and you look at Kubectl, we just basically use two commands. One is you can get the events for a certain namespace, and that's in that back slide there. And it's very verbose, right? It's very long on the screen. There's more information. It's not super detailed. You can dive in, of course, get the raw data, but then these things don't stick around. Our server is configured a little bit longer, I think for an hour for these events. So you see some of these things here, but you get events and you can start seeing started, created. That's all pretty normal, right? And then say you specifically want to see what's happening on a particular pod, a container. You can go and query. You can describe it, and then and I probably worked with Kubectl for months and always ignored these things at the bottom, right? Because I didn't understand them. They were too verbose. I didn't pause to look, right? Because and then because a lot of times you just see the started container and you go on, and then it gives you some obscure message if not. And it doesn't necessarily show you like your log files of your pod. So it wasn't super helpful for me to view it at the command line, right? Because I wasn't seeing all these things were restarting, and so just being able to be aware of events. So that was one of the reasons we did this webinar. Just be aware that there's a ton of events coming from your system, from Kubernetes, and you can view them raw. You can shift them over to a monitoring platform where you can start seeing them over time. Because as I was saying before, the big problem is a lot of times your outages, we wish we'd noticed them right when they happen, but they could happen on Friday before the weekend, right? And then a lot of times you don't actually know what's normal. And I'd say like that's one of the problems. If I show you a 1 hour window and there's a lot of events, is that good or bad? And if you can't look in the past, like what was it last Friday? What was it last Monday, right? You don't have anything to compare to.
Ultimate issue, right? Like I think again, as a customer success person that works in kind of more of a technical role, I obviously I know I'm not an on-call engineer, but I had on-call rotations, and I was getting on, and a lot of times I felt like I couldn't contribute because of that. I didn't have that context. I didn't understand that stuff well enough to understand how to even go back. But there's a lot of questions I always had from kind of like kind of an inexperienced level. When I see issues with like a pod, one of the first things I'm always asking is like, well, like Kubernetes is meant to scale these things out, but like how many pods am I currently running? I'm not verbose enough at terminal because I don't use it every single day, right? It's like that muscle memory. If you use it more, it's very easy to go around it. But if you don't, like, it becomes very problematic. So like, I know for myself, observability tools and platforms are like, they're critical to me, right? I need to be able to see it, not only from the events that are there, but the metrics that are tying to it. And you know, something with like control stack is actually pretty useful, I know for myself, because it gave me the opportunity to be able to go in and not only see those pods that are running, but be able to look at the metrics, be able to correlate it with the events, and can also see the logs too. Like that was a huge thing. I would have, you know, I don't want to go into, you know, some other log tool and go into that, right? I remember when I used to have to do log queries, they took so long just to be able to get back some sort of useful information. So it's like querying in the right time window. Something like control sec definitely helped me out with that.
Yeah, and I think that's, you know, we're talking about, I think we're talking about like the, you know, kind of last 10 years was like the development of a lot of these monitoring observability tools that did like one or maybe two things well, right? For example, metrics. Even in this example here, we're talking about Kubectl. It's like you've got metrics, you've got events, and you've got logs. And a lot of places, you know, you'd ship logs to one place and metrics to another place and events to another. And now you see like the next generation of observability tools, and you know, control stack in particular is used for, you can send all of it here, and then we'll unify these contexts and connect, and enable you in one workflow as well as additional workflows. But you know, here's an example of our, and it also gives like a different visibility, right? So you've got these, and for me, you know, that's one thing I was going to mention is, you know, for me, one thing, even though I've been working in the industry for a long time, one thing that's really difficult for me is remembering verbose command line commands and flags, and and especially for unfamiliar concepts. And the biggest problem you get with Kubectl is not knowing, unless you spend time, and of course, a lot of engineers, including myself, jump ahead and just try to figure it out. You know, where's autocomplete? It's not working, right? But I don't know what kind of I didn't know what kind of resources were available. I didn't even know like I could do Kubectl get events, right? Or you know this Kubectl top, right? Like what's my CPU usage? Like a lot of times I'd have to jump into AWS console to see what the nodes we're using, and so we jump into metrics here, and so this is showing basically the Kubectl command. So you got Kubectl top, which if you're familiar with the command line is top, which kind of shows CPU and mem usages, and it kind of shows your different basically what you'd expect, like your live usage here. And but this is like at this moment, right? Or like the last time it was collected by a metrics server. So I don't know how to query this for, yesterday, right? Like, so I say, oh, one of these things is using 1% CPU. I don't know. Is that normal? I don't know. And then, that's like your nodes at your infrastructure level. And then you have like the pods, which is typically more like your application level. And so, we have our agents running, and they're only using, a small amount of CPU at this time. But is that normal or not? I don't know. So, but the nice thing is you can, if you know that these exist, at the minimum you can scrape them yourselves and write them out to a file and sort it. But you can also use monitoring tools, and especially one like control stack is one you can ship these things to, right? So
yeah, and again, like I want to make sure that it's clear for the audience that's watching this, right? Like it's not that Kubernetes doesn't have some of these things available for you, right? Like you obviously do have the Kubernetes dashboard, you do have Kubectl that you can run and find a lot of this information. But really, like if you're starting to use this in production and scaling out, and you're starting to take on more customers, like just the complexity of that stuff really almost makes things like an observability platform like almost a necessity, because it's hard to correlate across everything, right? It's just too much for one human to do.
And I'll also say this, just also, in general with command line tools, they're not intuitive, right?
No.
You can't show these screenshots to people and, without explaining them to people, right? So, I'm running this command in this Kubernetes, and like, you don't know how nodes relate to pods, and, the conceptual it's very hard to convey the conceptual diagram
Sure.
of what these things actually represent, right? Like these are computers running what, right? Like you're not even tying these pods to, I have the same namespace, but like which of these pods are running on which containers, right? So
Right. And to your point, where it's like you can even see from these examples you have here, right, Chris? It's like not only do you have to know like the basic commands, but you also have to think of like how to filter them and like what parameters you have on there, right? Like you mentioned namespaces, like you have to know to add that as a flag on your command itself to know that you're looking at the right namespace, right? And it's like just all those things again, if you're doing it regularly, right? If you're more of a developer who's constantly spinning up test environments, stuff like that, like you just get used to it, right? It's constantly there. But I know, again, for someone like myself, and if it's okay with you, Chris, I'll kind of segue into control stack a little bit. Being able to take it a step further than just looking at it from like terminal and seeing the events populate that way, like it was critical to me. And there have been a lot of there's observability tools out there, right? There's lots of things you can look at, but control stack has made it much easier for me because it adds like an extra layer of stuff. So kind of I'll just give you a couple minutes, I'll show it to you, right? Like for example, in control stack, we do a way where we want to unify and capture the relationships of your clusters in your stack, right? In this case, like we're specifically looking at Kubernetes, right? If we kind of come in here, I'll kind of give you a view. You can see all the events that are funneling into your system. Right now, I'm just looking at Kubernetes events here, but you can see that's again because I'm filtering by Kubernetes in particular. If you have other text, you can see them here. But it gives me a quick way to filter my events, right? I can look at it by a specific time slice, right? Like what's happening around 11 o'clock. I can see all of the events there specific by time. And use cases are all different, right? Maybe I care about a time. Maybe I care about just warning errors because you get a lot of those, events that happen that aren't really anything you need to worry about. We give you a way to filter that. I can look at like my web apps namespace. I can see low-level details tying to those events. I could go into it in more detail if I really wanted to. What's really cool about control stack is it gives you that combined view, right? Like where I can look at my events, but I can also correlate it with the metrics tied to that namespace or pods or whatever it is. Like I create these dynamic metrics dashboards I didn't have to go and create on myself. I just dynamically generate them, right? And I can correlate this stuff side by side. So if I see something going on with, my web apps namespace, I can immediately correlate that with the metrics here. Things like describe, right? Instead of having to go into Kubectl directly via terminal, I can do it directly in control stack and can see, those Kubectl outputs here. But I know for me personally, right? And again, I've used monitoring and observability tools for really where control stack gave me most value was that it gave me a true like idea of what the architecture actually looked like, right? At this moment in time, right? This is less than 2 minutes of work to be able to look at this. It's not hard, right? Because we're capturing these relationships directly inside your system, right? So I can look at that web apps namespace. I can look at the specific pods running right now and what metrics are tied to it. I don't have to know the naming conventions. I can get directly to the logs. I don't have to know how to actually go in there and search for that stuff. It's already filtered the right way. But I can even take it a step further, which I think is, kind of ties into what our next webinar will be around, which is around cloud providers, right? You can run your own bare metal machines in your own closet, and it's possible. But the fact is that most customers I think most people are using services from the cloud providers directly, and understanding not necessarily just how your Kubernetes cluster is working, but the workloads, where they're running, and what that health looks like. Being able to correlate that stuff in one central location has really opened me up in my knowledge to understanding how these clusters work and like really where problems are and how to spot them much faster for sure.
Yeah, this is kind of what I was talking about, like, the intuitiveness of like the command line tools not, being very lacking, right? I spent lots of time trying to figure out how things connected, like pods run where, right? Oh, they run on nodes, but like, how do you know that unless you're reading through documentation? But with, tying, basically we can illustrate that here, and it becomes much more intuitive for even someone who's never worked with, maybe they don't understand exactly what the concepts mean, but you can see how the things relate. Like there's a namespace and there's some pods related to it, right? And there's an instance and running these pods, because another thing that used to happen a lot for me is, you copy and, Kubernetes is very verbose, right? Like you need to be specific on what you want to see. So like if you want to see what's running on nodes, you'd have to like copy the node ID and then put it in your command. And then you basically, every one of those lines there would be running a different command with, a different input, and
It's like accidentally capturing the like blank space in there when you go to
yeah.
copy, and it just never works.
Yeah, so as someone, do you think like you're keeping this context in your head and shifting around, like, this conceptual graph of what, is running in Kubernetes, and it becomes this is why like Kubernetes is like very intimidating and seems like such a complex tool. People don't use it because there's so many granular things. It's actually quite simple. It's just very granular, and simple things combined can appear complex. And so,
Yeah,
you know,
you don't know how to easily connect them. Like it's just like you said, it goes back to like maybe some of it is valuable, but it just seems like a lot of noise because you don't know how to connect them the right way.
right, exactly. And then so, control stack, we're just representing data here in control stack as well. But, one of the powerful things is taking like the logical concepts of Kubernetes, how things are laid out, but, also the events there, and navigating through it in a way that is intuitive, like you can, an explorative, right?
Yes.
So you can click things around and look at how different things work versus like you can't explore on the command line without a robust autocomplete tool that is probably highly customized for your thing, which I actually never used because I have not found how to do this. I'm sure there is something, but that actually is hard to do. Maybe with some of the Gen AI stuff, but also very specific to your cluster, it's hard to do. But control stack, even showing the metrics there, right? And another problem, as a DevOps engineer, especially working at a place, there's a tool for everything, and unless you've got a list of bookmarks, like how do you even link your, as a new person coming to your team, how do you show them, oh, here's your metrics, here's your events, here's your thing, and how do they all tie together? That was always confusing because a lot of people would see like the log tool, but didn't know that they could see metrics, or
Yeah.
they could see their events, but they didn't know that they could see aggregates, right? And so this, for me, makes it, it's just it unifies basically so much data. It's not, which then allows you as a person to like build higher like level concepts in your mind, and then it can also present them in control stack, but just lets you work at a higher level.
Yeah.
Which if you're really skilled at Kubernetes, might not be valuable, but I say when I first came in, and if I didn't know Kubernetes, or even now, like I don't understand all the resource types, but control stack that can at least see what they're here versus iterating through and running kubectl get x or get x, right? Like I
Well,
can see so much.
I'll just point this out, Chris, when you talk about like if your skill set's already around Kubernetes, like yeah, it's like okay, well you already know this, but like, and I think anybody who's watching this, and you probably are one of these people who understand this, Chris, like it may not help you in particular, but everybody's skill set is different. Your entire DevOps team, the people who are on call, they don't have the same experience level. So even though like it may not do something like the highest level of experience, the fact is that it up levels the other people, which frees you up. Because I know, at least in past experiences, like if you're the person with that skill set and I'm on call with somebody else, we're going to spend 20 minutes wasting away our time. We're hurting our SLAs, but we're eventually just going to ping you and ask you to stop what you're doing and come help, right? So like, even from that standpoint, up leveling the other people on your team so that they can have that type of skill set, I think is crucial as you scale out your companies, right?
Yeah, it definitely is. I feel like some people like to be that person that everyone depends on, but for an
Yeah.
org itself, it's not necessarily the best. And honestly, if people understand it at that level, can do way more for the company than just be the on-call support person, right?
Yes. Yes. You want to
Um,
free them up to really kind of make like help with feature velocity and get the value out to their customers, right? Versus just maintaining the system.
yeah,
So yeah,
exactly.
absolutely. Well, I tell you, that's primarily I know what I wanted to cover during today's webinar. Obviously, if there are some questions, you're welcome to post those into the chat. We'll do our best to try to answer that. But really, obviously, I would just say for us, like, thank you so much for joining. If you are interested in getting a demo of our product, or if you just had some follow-up questions that maybe you don't ask in chat today, reach out through support at Control Stack. It's coming to this guy right here. It's not like some random person. We'll have the right people answering the questions and helping you out. And I love giving demos. I love showing our product and explaining how it can really help these users. Because as a customer success person, like that's my primary focus is really trying to enable the people using the product. So If that's something you're interested in, please reach out via support, and we're more than happy to talk. Chris, anything you want to add here at the end?
No, you covered it pretty much there, but yeah, Jason's definitely a great person to talk to if you're want to talk a little more technical, way deeper, more from the coder side of you, or the support SRE type thing. I'm also available too. You can send an email to that as well, or chris@controlstack.com. I don't have the link there, but
yes. Same, right? Chris at Control Stack, Jason at Control Stack. Just let us know. We love working with our end users and people in this industry. So again, just general questions, you're welcome to reach out, because we love hearing from you. But with that said, Chris, I think we can probably go ahead and end the webinar here. I really appreciate the time, and we'll have another webinar coming up in the next few weeks, focused around cloud and cloud providers and how we can tie it back into your Kubernetes technology. So hopefully, if you guys enjoyed this call and this webinar, you can join us for the next one. But that said, thanks again for joining, and I hope you have a good rest of the day.
Thanks, Jason.
Thanks.